So for today, we're going to start with the kitchen ventilation 101, I like to call it, where we just go through the kitchen hoods, cooking appliances, and the control systems and all that. We'll move into the grease ductwork, as I mentioned, Jeremiah's and Van Packard, and then we'll finish off with some pollution control units and grease filtration options. So to start with kitchen ventilation, I like to start off with just describing the three goals of what a kitchen hood is. And the first and foremost is the exhaust heat and the effluent. Whether that's, even the smells. We're just trying to keep everything and that heat and that cooking heat inside the hood and get exhausted out the building. Ensure safe working conditions, with grease accumulation and kitchen fires, and then maintain a balanced system throughout the entire space there. So this is a typical setup where you'd have your hood over some appliances, exhausting up to a dedicated exhaust fan, and then you can have a dedicated makeup air fan delivering makeup air either right at the hood in a supply plenum, almost creating like an air curtain, or we can also just disperse this air throughout the space and makeup air that way. So as we get into the kitchen hoods, there's two types of kitchen hoods, and some people get a little confused sometimes of what the difference is between type 1 and a type 2, and all it does come down to is grease applications and fire systems. Type 1 hoods will have a fire systems, type 2 hoods will not have a fire system. So anytime you have grease producing foods, think cheeses, meats, oils, anything that's going to be creating grease, we must put it under a type 1 fire system, and it must have a filter and fire system in it. Typical appliances for this are griddles, fryers, charbroilers, anything you might see, in a burger restaurant, stuff like that. You also require that UL 710 listing as well. And then type 2 is really just for heat management. There's no listings required with these, no filters and no fire suppression. And there's also no fan interlock required. We'll get in a little bit of the controls later on, but that is one of the distinguishments as well. So for these, it's mainly just dishwashers. A lot of dishwashers for these, or ovens if you're thinking like a bakery where they're just baking bread. There's no grease production in that, so we can use a type 2 hood over that. If you have any other questions, make sure you just get the appliance cutouts from the food service vendor, and you can always send those over to us and we can review those and determine whether it's going to be a type 1 or type 2 hood. So some common UL listings and codes, I'm not going to go through all of these, but the main ones are the grease hoods with UL 710, as well as the exhaust fan UL 705-grease. That was formerly UL 762. So you might still see reference to UL 762, but they have merged it to the UL 705, and they call it UL 705-grease. And then for fire suppression, UL 300, and then grease ductwork has its own codes as well. And then you'll also see some reference to the International Mechanical Code, the IMC, specifically referencing the airflow rates for these hoods. So we'll get into airflow rates as well. Okay, so some quick little code stuff. I'm not going to go through all these, but just some highlights here. So just to kind of reiterate what we're looking at with the hood and what the requirements are when you're sizing a hood. First and foremost is the operation. A type 1 hood must have automatic interlock with an exhaust fan. So what that means is that if they start cooking without actively turning on a switch or anything like that, the fan still needs to automatically operate. And that's just done with the temperature sensor inside the hood, and it also compares it with the temperature sensor in the room. And once there's it senses a rise of temperature inside the hood, it'll automatically turn on the fan. Clearances, these hoods need to be installed with a clearance to combustibles of not less than 18 inches. There is some ways around that with zero clearance options that we can provide as well. And then overhang, on all sides of the hood, we require a 6-inch overhang. That does not apply when the hood is up against the back wall. The back wall does not need that, but all other sides need at least a 6-inch overhang for canopy type 1 hoods. If you go to an island hood, it will increase to 12 inches on all sides. So here is a typical hood. I'm actually going to go to the next slide here, showing some dimensions. So this is a typical setup with the hood. One other thing you need to keep aware of is this requirement here is 48 inches max from the bottom lip of the hood to the top of the cooking surface. Needs to be a 48 inches max to ensure that we're keeping that heat inside the hood. as well as this 80 inches above finished floor from the bottom of the hood to the ground. We need that 80 inches above finished floor. You cannot go lower than that. You are able to go higher than that if you keep this 40 inch max, but you cannot go lower than 80 inches. And then, we can go anywhere from 48 inches deep all the way up to 72 inches in 3-inch increments, depending on what appliances we're looking at. Okay, and then some more clearance options, as I said. So typical, you'll get the 3-inch uninsulated airspace on the back of the hoods. We can also add 1-inch layer of insulation on all sides to get some zero clearance options. So if you are looking at a wood structure or something like that, an old space where you can't redo that with a metal stud or anything like that, then we do have some zero clearance options that you can look at as well. Different types of hood configurations here. The most standard is that wall canopy hood on the left there. Then you have a double island hood configuration. Most of the time with those double island hoods, they're actually just 2 wall canopies back to back, and that can serve a double island situation. Or you have the single island hood, which does require a lot more CFM than a wall canopy hood, and that's 12 inches of overhang as well. And then very rare do we see these back shelf low proximity hoods, but they are much closer to the surface, and they can they can have a little bit different listings behind them. The only time I really see these anymore is in like a food truck or something like that, where it's very tight spaces, so they are pretty rare. Just a couple more pictures of what these hoods will look like. And we can also do tapered fronts as well. So on this wall canopy hood on the left here, sometimes you can't get 80 inches above finished floor on these. So we can actually have a 24-inch back, and it will come out, and then it'll actually taper up to the front and only have a 12-inch over on the front. So we can actually have the bottom of the hood up here and allow for a little bit tighter space. So when you have a low ceiling applications, you might see us recommend a tapered front hood. They do require a little bit more CFM, as you are losing a little bit of performance from the hood as well. Okay, so now grease filtration. So type 1 hoods require grease filtrations. We have 3 different options, starting with the baffle filters. Going from left to right, we're looking at cheapest, least effective to most expensive and most effective, as well as pressure drop too. As you get to the grease grabber filters on that right, it's going to have a lot more of a pressure impact on your system there. And then you can see the process there. So baffle filters are just the inertial impactation there, just like a typical filter. And then the extractor filter uses a centrifugal force. You can actually see it down here. So air passes through this, and it actually creates this corkscrew style airflow pattern, which is also pushing grease particles to the filter in addition to the inertial impact. And then the grease grabber will do both of that and get about 100% there. So different options. Most of the time, you're probably going to be in this middle range. That is the most commonly used. Okay, so cooking duty ratings. So we go from light duty to extra heavy duty, and these just depend on which appliances you're looking at. So the electric range will be in the medium duties, ovens and light duties, anywhere from the solid fuels up to the extra heavy duties. Solid fuel is a whole nother ball game. You really have to be careful with solid fuels. It's a very, very high fire risk. They require their own dedicated hood, and you don't want to put them next to fryers or anything, because there are these chances of these little embers, floating around. So they require their own hood. I typically recommend putting full vertical end panels on them to just really secure them. So if you have a solid fuel application, I really highly recommend reaching out and working with us, because they can be quite challenging at times. Okay, so speaking of the IMC, the International Mechanical Code that I mentioned earlier, that references airflow rates. So sometimes you'll see us size a hood, and we'll send you something, at 250 CFM per linear foot for a gas range charbroiler, and you might think, wow, we're way under what we need to be. And that's just because we're listed. An ETL listed hood is allowed to run at these recommended airflows from Greenheck. We don't have to go to the IMC ratings. The IMCs are for unlisted hoods. If some mechanical contractor wanted to build his own hood that wasn't listed, that's what you need to run those at. So just a reference there. And then just some more commonly airflow rates that we use. So the sloped front is those tapered front hoods, as you can see with the wall canopy 200 CFM. If we do that tapered front, we do bump up the CFMs a little bit on all these, and then islands get quite big too, as well as back shelf hoods. So, and these are all, and typically, so what you do when you size a hood is, so I have a quick example here. We have a deep fat fryer, gas range, and a griddle. They're about 78 inches in length. If we put them all together with the 6 inches of overhang on each side there, we'll get a 90-inch hood or 9.5 feet of hood there. Now we look at these appliances, and we have a deep fat, we have a fryer, we have a range, and we have a griddle. If we go back to this page, we have a range, a fryer, and a griddle, and we're looking at 225 CFM or 250 CFM. Because the gas range requires 250 CFM, we have to go with the most. So we have to go with the highest value there. So as we go through this again, with the gas range, 9.5, we'll use 250 CFM per foot, and we have an exhaust rate of 2,375 CFM. So that sometimes, you know, when you look at these kitchen hoods, what I see a lot is there's a lot of focus on the BTU ratings, stuff like that. It really doesn't come down to that when you're sizing a hood. All it comes down to is the type of appliance that's being used. And then you look at the heaviest duty appliance and you size the whole hood according to that. Okay, so speaking of the vertical end panels that I mentioned with solid feel, so we have two different options. We have full vertical end panels, and I apologize, this picture is a little bit out of date here. These actually go all the way down to the ground, and they are full vertical end panels, and they'll basically enclose the hood and really increase that you know, that capture and containment rate, as well as it does reduce the clearance or the overhang options. So you can go down to technically 0-inch overhang with full vertical end panels. So if you are in a tight space or something like that, we can look into full vertical end panels. And we can also start to reduce the exhaust rate as well with full vertical end panels, because we are keeping everything nice and tight inside that hood. As well, you know, even if you don't want a full vertical end panels, quarter end panels also work as well, because of situations like this picture where doors open, pressure changes within the hood or within the space, and it might impact some of that capture and containment with that hood. Okay, getting into exhaust fans. Sorry, just taking a quick drink of water. Okay, so getting into exhaust fans, all the exhaust fans need to be listed with UL 705-grease. You might still see reference to UL 762, like I mentioned. And then each fan will also need a hinge kit on the curb. If you're looking at an upblast fan, you will have a hinge kit. You'll have a grease cup. It's not shown here, but it'll be right there. All these fans that are required to have a grease containment option as well. Okay, and then supply air configurations. So typically you see about 80% makeup air. It's not, you know, it's not like it's a requirement that you have to go 80%. You can go higher, you can go lower, just depending on what balancing you might be doing within your space. But typically you just go 80%. You can supply that right at the hood and almost create like an air curtain, like I mentioned. We also have this option as well, where we're doing makeup air right into the hood. And this second option with the green line is actually a different connection, where it's tied into your air conditioning unit. So you can have makeup air curtain type thing, and you can have air conditioning right there as well to help keep the staff nice and comfortable. Going into makeup air, so we have some options with tempered MAUs with direct fired and indirect fired gas. Now, direct fired gas is 100% acceptable in kitchen applications. The only time we can't do it is in sleeping quarters. So there's no issues with doing direct fired gas with kitchens. I do know that you know, there is some hesitancy around direct fired gas, so there's no problem going indirect fired gas, whichever you might prefer. We can do cooling options on these as well. I highly recommend doing cooling with kitchens. I know I don't believe it's required by code, but it might be. I see a question coming in, is AC required by energy code? When I now read it, it appears so. That might be so. That would be news to me, to be honest. And I will look into that right after this, and I'll follow up with you, Daniel, on that one. but as far as I know, it wasn't required. And typically I would always require it because I do get a lot of complaints in the summer months with that makeup air is not tempered with cooling. Okay, moving into the DOAS as well. So you can go with the DOAS unit as well. You don't have to just go with these makeup air ones. With the DOAS unit, I would not supply these right at the hood because this is an expensive unit. It's costs money to cool this air down with the DOAS unit. So you don't want to just put it right in the hood and then out to space. So this would be more of an application where you're supplying it into the entire kitchen area, or even if you have a small restaurant, think like a takeout, like a Shake Shack type thing, where you can just have a DOAS in the dining room and it actually will serve dining room tempering and makeup air as it just flows towards the hood. So that is an option as well. And this is kind of what that looks like. So common setups would be a rooftop unit serving that the air conditioning type stuff, and then a makeup air unit just serving the makeup air for the hood. Now you can combine the makeup air and the rooftop unit into a DOAS unit and kind of serve both aspects at once, where you're tempering the space with air conditioning as well as makeup air for the space, for the hood. We're seeing a lot more of this nowadays. Okay, so some more controls or more code stuff regarding controls now. So like I mentioned, the controls need to be automatically interlocked with type 1 hoods, as well as there needs to be a temperature differential between makeup air, and the air in the conditioned space shall not exceed 10 degrees Fahrenheit. So that does get a little confusing at times, and there is a lot of exceptions around this. We can get away from this if you're supplying the makeup air right at the hood, as well as if you're having, like if you have that DOAS unit combined with, serving air conditioning as well as makeup air in one DOAS unit, you can also get around this. There is an exception that says that if your makeup air is the same as your conditioning unit, then you don't have to abide by this. So in essence, this rule was created to prevent, too much uncomfortableness in the space, and really to prevent staff from going up and turning off anything unnecessarily. And then moving into the International Building Code Chapter 904 for automatic fire systems. This just basically says about where you need to locate the manual activation device and how it needs to, suppress and work with the fans as well. So more on the codes here. So this is just what happens in the event of a fire. So once the hood is, or the fire system is activated, the exhaust fan shall go to 100%, and the makeup air should be completely off. So that's just something that we have that automatically in the package control. So it's nothing that you guys need to worry about too much, as long as you're specifying a package control system from your hood manufacturer. That should be no problem. Okay, and so now getting into some different control options we have. So we have the constant volume control. This is, we'll have the interlocks with the exhaust fans, makeup air, fire system, and appliances, constant speed. So once this activates, it's you can either touch a button to turn it on, or like I said, there's a button on this thing you can activate to turn on the fans, or like I said, once the temperature sensor inside the hood starts to sense that the cooking appliances are on, it will automatically turn on. And with constant volume, it's automatically going to turn on to the top speed. With demand control ventilation, the temperature sensor inside the hood is going to look at the temperature sensor in the space. And as the temperature sensor in the hood starts to rise every 5 or 10 degrees, that is an adjustable value. Every 5 or 10 degrees or so, it'll start to ramp up more and more on the exhaust fan all the way up until it gets to that max point. So here's kind of an example of that with constant volume airflow. So once the hood is on, it's just going to be running at 100% the whole time. With variable flow, it'll start to match your loads a little bit more. So if you're not cooking as much in breakfast as lunch, you don't have to run your exhaust fans as hard. So I highly recommend variable air volume whenever you can. And then kitchen hood fire suppression systems. So ANSYL R102 is what we typically use. You can do appliance specific coverage, where if we know the appliances, we will size them at the factory as much as we can with the hood taps and all that according to the layout. So with that said is what we get when we design the hood, that layout cannot change. The fires need to be where the fires were designed to be. With the overlapping coverage, it's more of a broad coverage, so you can just put drops throughout the entire hood, and you have a lot more flexibility of what you can do with the appliances and where you can locate them. There are still some exceptions, primarily with maybe back shelves on certain hoods, this type salamander grill that's in this picture shown here. Those type of things, might fall into an exception where overlapping coverage might not work. So there just are some exceptions there as well. We also have an auto scrubber hood, or a self-cleaning hood is what they're also called. Basically every night it will go into this wash cycle, and you can do it every night, you can do it once a week, whatever you might want to do, and it'll basically just wash behind the filters with some detergent and hot and cold water, and just keep everything nice and clean. It's really high robust system here for high quality systems. And then residential hoods as well, with integral fire suppression. We can do UL 300A certified, NFPA 101. We can have recirculating fans or integral fans recirculating, or we can have external fans as well. Okay, so now we're going to get into some grease duct stuff. So that was, we're going to be going away from the hoods a little bit here. Let me just take a drink of water. Okay, I see some questions coming in. I love it. Looks like most of these I'll probably get to at the end. So, all right, as we go through these grease ductwork code requirements now. So, there's a lot of codes regarding the ductwork and the grease ductwork as well. But if you ever want to just send it over to us, we're happy to work with our manufacturers and look to make sure that we're providing the best grease duct there. But basically, there's a grease duct test. Make sure that there's no leaks. They do a pressure test, light test. Sometimes you'll see them do a smoke test, just stuff like that. Air velocity, make sure we have the proper air velocity to keep that grease moving within that duct and not just accumulating. And then separation of grease duct systems, where that's pretty common sense as well. And then getting into more duct systems, I don't need to read all these, but duct cleanouts and prevention of duct accumulation. So just make sure you're cleaning the ducts, as well as having those duct cleanouts in every 10 feet or so. Come on. There we go. Okay. All right, so we got a quick video for you. I'm going to keep it on mute, but this is a 30-minute 2,000-degree test that they do at the factory. So, factory-built grease duct is required to do this test. It's a 30-minute 2,000-degree test. And what they did on this one, we decided to build our own, or they decided to build their own, field welded test to just demonstrate the differences in quality that you get with the factory-built UL listed product versus something that's built and welded in the field. So as you can see, that duct is, it's 3 minutes into this 30-minute 2,000-degree test. That field welded duct is already collapsing, and the fire is basically outside the ductwork now. And as you pull it apart, you can see that it's pretty much completely collapsed, whereas the Jeremiah's duct is still intact and it contained all the fire as it needed to. So here's some pictures as well. One other aspects of this that I like to point out too is with Jeremiah's, with factory-built grease duct, the manufacturer, Jeremiah's, will also provide all the structural supports as well. And that's key too, because I've seen in my experience a lot of these structural supports. If this fire gets outside the duct, then a lot of times that structural support isn't the best. And once that collapses, then the duct just collapses in the space, and now you have a fire in your entire space. So in the end, what this grease duct is designed to do in a fire is keep the fire contained within the grease duct, and that is what factory-built grease duct will excel in. So what Jeremiah's is a manufacturer that we rep. They are a German-based manufacturer. They have a plant in Atlanta as well. They do round grease duct. They also do some chimney duct and flue stuff as well. But for now, we're just gonna be focusing on the grease ductwork. So typical is 18-inch clearance to combustibles. We can do double wall or single wall. Right now, we're just looking at single wall. As we go into double wall as well, it's the clamp style mate together ductwork. It's very easily installed. All the parts and pieces are delivered with these, as well as the supports, as I mentioned. With double wall, we can also go to this UL2221 listing, and that is a zero clearance to combustibles. So it is actually its own chase, and it's basically its own chase. So you don't need a dedicated chase if you have a UL221 listing. It does get quite big though, to be honest, because you have your inner diameter plus 6.5 inches on also, so it is quite big, but you don't need a dedicated chase for this one. We can also do these for wood-fired pizza ovens, where we direct tap into wood-fired pizza ovens, chimney high temps. We have all the built-in access doors. Jeremiah's will also be able to provide you with all of the really high quality 3D drawings as well, that you can look at as well. I do see a question just come in: Jeremiah's system available in rectangular duct? That is where we're going to go into Van Packer. So Van Packer is who we rep for our rectangular ductwork. Same listings that Jeremiah's has, same type of clamp style made together, flange to flange. It's just rectangular versus round. That is the only difference between these. We can also get that UL2221 listing where zero clearance to combustibles as well. One other addition to these is a reduced slope requirement for these. With factory built grease duct, you can actually reduce the slope requirement for these runs. So the requirement, and I apologize, there's actually a typo on this slide right here. It should actually be 1/8 of an inch per foot. So with a field welded grease duct system on horizontal runs, you need to have a 1/4 of an inch per foot slope back to a hood or back to a grease trap, just to prevent the grease. You want the grease going back to somewhere where it can be captured. With factory built grease duct, you can reduce that to 1/8 of an inch per foot. So like I said, I'm sorry, I apologize for that typo, but so that is a benefit as well for factory built grease duct, and that applies to Van Packer or Jeremiah's. Okay. All right, now we're going to get into some grease reduction and filtration options, pollution control units, as well as an ozone generator that we represent as well. Okay, so pollution control units. Typically, most of the time, what you're going to see these on is certain jurisdictions inside the, maybe inside the city of Boston, where smells are very common. You can use these to mitigate smells. Or if you're using a solid fuel, you would almost want to use these pretty much every time as well. Most solid fuel applications will use a pollution control unit on. So basically, what these are just a large filter bank system, going to pre-filters, MERV8 filters, HEPA, carbon filters for odor, and we can modulate these pretty good and provide 3 of these, 4 options, all of the options, whatever you might need there. These will also have its own fire system as well integrated into these, because these are filters and it is a grease application. This will all have its fire system as well. So you'll have a fire system at the hood and you'll have a fire system here. There'll be independent fire systems, but they will be interlocked together. So if one goes off, the entire system will go off. So that's something to keep in mind as well. There is some high maintenance costs with this, with that being a fire system, as well as all these filter replacements. It's a lot of filter replacements, which is the most costly. Going into Trion, so we also represent a company called Trion, and they make electrostatic precipitators. So basically just some charged plates within this unit here, going across a pre-filter into the charged plates, and it'll just collect that, and then it'll automatically wash every night. So just another option to help grab that grease and collect it somewhere. And this will also have its fire system as well in there. And both these PCUs, this one and these ones, can be mounted indoors or outdoors, but they are quite large. I just want to reiterate that. They do get quite big quite quick. So here's some more pictures of the Trion system with the fire suppression system. You have some filters as well as the ionizing collecting cell and the control panel as well. So just some quick little breakdown of the differences here. So PCU's first cost is going to be lower than the electrostatic precipitators, but the annual operating cost is going to be much higher in that pollution control unit. And that mostly comes down to the filter replacements. It can be quite costly because you have to do it about 4 to 5 times a year. So there is some, it really just comes down to maintenance, but this has an automatic daily wash. It is more of a high-end system. So if you want to have that high-end system, the ESP is more robust. And here's just an example of what we're looking at with grease fire risk. And this can apply to PCUs. This applies to grease duct. But for right now, we're going to be looking at the grease duct. So there is scheduled cleanings that these restaurants need to have, and they typically these cleaning companies will come in the middle of the night and they will have to clean the system of grease. They'll get up into the duct, they'll open up all the clean outs, and they'll clean it up, as much as possible. And it's a pretty nitty-gritty job, and they do have quite difficulties, keeping staff to do that work for them. So one way to, and as you can see, when you just clean it, there's very low risk for grease, but as you get closer to your scheduled cleanings, that risk does go up. So today we're going to be we've had AirMade for some time. This is AirMade. They are an ozone generator and cleaner. And so what the science, the chemistry behind this is, we have odors and grease coming through, and then we generate the ozone. And what happens is that we get byproducts of water, CO2, and then minerals and sulfur oxide. So just some minerals and some water and some carbon dioxide. So nothing harmful, because all that ozone is being used up. We're not just throwing ozone into the environment. So what it does is, reduces the grease, which reduces odor and as well as kills bacteria, thus enabling improved fire safety and happy neighbors with those mitigated smells, especially. And it's very easily installed, low cost, and low maintenance. So we're going to get more into this. Here's just some more pictures of what these units look like with their ozone generators there, their cells. You can see them inside the duct there. So here's an example of how it's installed. So you have your hood. Your AirMade is actually tied or installed next to, kind of adjacent to the grease duct, and taps into the side of it after it leaves the hood. And we want about at least a 2-second minimum of dwell time to make sure that we're using up all that ozone with the grease particles. So we have to make sure we have somewhat of a decent sized grease duct run. We don't want to just go right out the back of the building or something like that. So here's kind of an installation detail for this. This is all compliant with NFPA 96. We've gotten this, or this is all approved with all that. We'll actually ship out pretty much all of these connections with the AirMade as well. But essentially, we have to have about 75 to 250 CFM, roughly in that range, depending on the size of the AirMade. We have to have about that much of airflow, what we call bleed airflow, coming across the AirMade to grab those ozones and get sucked into the grease ductwork there. So here, just a little bit more of some pictures of it. So we'll have some construction with the AirMade, getting that bleed airflow and sending it in. We also have some fire smoke dampers in here as well to prevent anything going back in. In the event of a fire, we'll completely shut this off and make sure that we're not sucking in air as the fire occurs. So with that, I want to look at some examples here of PCUs versus AirMades. So AirMade is a great solution. The one thing to mention though, before I get into this, is AirMade cannot be used for solid fuel. So solid fuel, you're pretty much going to have to go with the PCU no matter what. We do not want to use this with solid fuel. Something with the ozone and like embers that can enter into the ductwork, we don't want them to interact at all. So just looking at a PCU for AirMade, especially if you're looking at, trying to keep a better system, trying to keep, the odors down, We're looking at those comparables. So you can see that PCU is going to cost, $15,000 to $20,000 in labor and parts per year just on filters and laboring and all that stuff. Whereas the AirMade is only going to be we call it maintenance free, labor free. There's really nothing you need to do. Maybe just every year, every 6 months, just make sure that the cells are still active, and that's pretty much all it is. So it's a very cheap system compared to a PCU. And here's kind of the first cost look. So an estimated for a PCU, you're looking at $90,000 to $100,000. Installation, another $20,000-ish. Now you're looking at about $110,000, $120,000, $130,000 for the first cost. And that's not even counting all your filters and all that you're going to have to, do every 4 to 5 times annually. And it's also very large, and typically the size of a small room, or it's going to, take up a large amount of roof space on your roof. With the AirMade, we're looking at maybe $30,000 for a unit, $5,000 to install that, and right there we're already at 25% less than a PCU solution. So, and it doesn't take up much room. You just need to install it above the plenum there, or in the plenum attached into the grease duct. So here's a quick example. So we had a Wahlburgers case study where we installed one of these AirMades into their Fenway location, and then we also compared it to their Hingham location without an AirMade. You can see that 6 months without that AirMade it's pretty shocking, to be honest. That's a huge risk and a huge liability, especially on that one. And then you can see the Fenway location had a much better result, much better cleaning system. You'll still need to you still have to have that required duct cleaners come out and service and inspect the grease duct, but their visits are going to be much less intrusive than the one on the left there. So great product for keeping your system clean and eliminating any odors, especially. And here's just a quick example here of what it looks like in the space. So that just has a connection to the bleed airflow, and it's just sending it right into the grease duct that's over there on the right, that big circle that you can see there. Okay, and that is it for the product side of things. So just to recap, we covered all the green heck, kitchen hoods, exhaust fans, makeup airs, controls, fire suppression, all that good stuff. Excuse me. And then we got into Jeremiah's for round grease duct, Van Packer for rectangular grease duct, and then we have Tryon for the electrostatic precipitators. Don't forget about Green Hex PCU as well. Finally wrapped up with the AirMade ozone generator solution there as well to really help on that odor and the odor mitigation control, especially there. So, okay, well, I really appreciate everyone for joining today. I know it's lunch hour, so I appreciate everyone logging in and getting a little learning in today. I hope everyone learned something, got some value out of this.